During this lecture, we will discuss questioning techniques that can be used to support an inquiry approach to teaching STEM. Have you ever asked Siri, Google Home, or Alexa a question but didn't receive the response you were expecting? Unfortunately, we often ask questions and receive responses that we did not expect or are not responsive in a way we hope they would be. Often, if your question does not prompt the answer you were looking for the first time, you might reframe the question so the device, or in some cases human, can better understand. When teaching, we need to ask questions to our students so that they can grow, construct knowledge, and learn through experiences. As educators, we need to develop questions that will inspire student thinking, which will lead to discussions, research, and further exploration. Throughout this lesson, we are going to discuss how we can frame questions so that we are meeting our students at their level during inquiry-based activities. Bloom's taxonomy can be used to think about the level of the question you are asking students. Bloom created a taxonomy of measurable verbs to help us classify observable knowledge, skills, attitudes, behaviors, and abilities. The difficulty of a question can be gauged by identifying where it falls within Bloom's taxonomy. The Depth of Knowledge Wheel is another resource which will help you to create higher-order thinking questions. During class discussions, it is helpful to develop a list of tiered questions for your class. Class discussions can sometimes die down, and so it is the instructor's responsibility to facilitate the discussion. Steps to creating tiered questions. Step 1. Identify the learning objective. Step 2. Determine the essential question that students will answer. This will be your umbrella question. Step 3. Write 3 questions using Bloom's taxonomy or the Depth of Knowledge Wheel. The first step to making a set of tiered questions is by creating a strong objective. In order to accurately identify how you want students to demonstrate their learning, reference the Next Generation Science Standards for the performance expectations of a particular topic. Performance expectations explain what students should know and do by the end of a unit. Now that we know we are going to focus on structures, properties, and matter, we can take a closer look at the performance indicator. Students who have mastered the 2-PS1-1 standard will be able to conduct an investigation to describe and classify different kinds of materials by their observable properties. This standard will be mastered over a series of lessons. In previous lessons, students learned about the properties of solids, liquids, and gases. In this lesson, they will be presented with slime, which has the properties of both a solid and liquid. This is known as a scientific phenomenon. The questions that the teachers and students ask will drive this inquiry lesson. By the end of this lesson, students will be able to distinguish between solids, liquids, and non-Newtonian liquids by describing the properties of each form of matter. Starting off, we want to focus on developing questions that will form a basis from which we can guide students through a lesson with follow-up questions. It is these essential questions, or focus questions, that will form a basis for a class inquiry underlying the lesson being investigated. Now that we have identified a standard-aligned objective, we can develop tiered questions that will help students reinforce their understanding of the states of matter. Question 1 has students draw on previous experiences with solids, liquids, and gases. A question that requires a learner to remember or repeat information is a low-level question. Question 2 will recognize that water changes states based on a temperature change. A question that breaks down ideas into simpler parts that can support generalizations is a mid-level question. Question 3 prompts students to assess if slime is actually transitioning from a solid to liquid. A question where the learner is making and defending judgments based on evidence is a higher order thinking question. Navigating wrong answers can be a tricky situation for a teacher. Most of the time, we want our students to get the answer correct, so we give in to temptation and give them the answer right away. This does not help your student to think critically, nor does it foster an inquiry-based approach to learning. Instead, implementing different questioning techniques and exercises will help the student build a path to the correct answer. Sometimes students may find it difficult to articulate new ideas as they progress through a lesson. Probing questions can be an excellent way to have students further explain their thinking. In response to such questions, students answering may, in the process, correct their own responses as they arrive at the correct answers. In case you are wondering, slime is a non-Newtonian liquid. Slime appears to change states when it is stirred or squeezed.